Hello friends, this video on aldehyde ketones carboxylic acid part 36 is brought to you by examfear.com. No more fear from exam. We'll do some numericals now. The first question says that how will you convert propanol to propene? So I have a propanol. I have to convert this to propene. The double bond. So how can I do this? If I can convert this to alcohol, I can easily do a remove water from that and make it propene. So to convert this to alcohol, I can use NaBH4. With this, I get alcohol, and from this, you can do minus H2O using sulfuric acid, and you get propene. This is done. The next is benzoic acid to benzaldehyde. I have this benzoic acid. I have to make it benzaldehyde, right? So what I can do is, I can convert this OH to Cl and then Cl to H. That's all, right? I'll get benzaldehyde. So I can react this with PCl5, PCl3 or SSCl2. Any of this I can react with. I get COCl, right? And this I'll add hydrogen. What will happen is Cl will be replaced with hydrogen, and what I get is benzaldehyde. Or I can do a reduction also, control reduction. The next is ethanol to 3-hydroxybutanol. This is my ethanol. To convert this to 3-hydroxy butanol. This is my butanol, and at third position 1, 2, 3 I have a hydroxy. This is by aldol condensation, you can see, right? So but for aldol condensation I need what? Aldehydes. So let me convert this to aldehyde. So I can do this with CrO3. I'll get this aldehyde. So once I get this aldehyde, I can use this OH minus, this NOH. I'll go for aldol condensation, and with this I'll get this as the product. This is 3-hydroxybutanol. Next is we have to bring out these conversions. Benzene to M-nitroacetophenone. I think you have done this. I'll not do this again. We'll do first Friedel-Crafts acylation. We'll make it acetophenone, and then I'll react this with nitric acid with presence of sulfuric acid. I'll get M-nitroacetophenone. We have done this. Benzaldehyde to benzophenone. This lets me do it. I have not done this. This is my benzaldehyde. I have to convert this into benzophenone. See, what I can do here is, if I can somehow convert this into Cl, right, and then I have this one acid chloride, then I can easily do a Friedel-Crafts acylation on benzene, right, to get me this. So to convert this into Cl, H to Cl, the first thing we have to do is we have to make it to OH. We can do oxidation. This will get converted into COOH. And then we have to convert this into Cl. I can use PCl5, PCl3, SOCl2, any of the method to convert this into Cl. So once I have the Cl, what I can do is I can react this with AlCl3 in presence of benzene. So this will be a Friedel-Crafts reaction, and this I'll get benzophenone. The next is bromobenzene to 1-phenyl ethanol. So I have my bromobenzene. This has to be converted to, let me just draw a line here. It has to be converted to 1-phenyl ethanol. So this is the expected product. So what I can do, I can do one thing. I can react with MgBr. Mg in this case, I'll make it a Grignard reagent. So once I have MgBr, what I can do is I can react this with CH3, COH, and then with water. And I'll get this product. Not that difficult. It is pretty easy only. The next is again we have to bring back, do this conversion. So let's see, the first is benzaldehyde to 3-phenyl propane 1-ol. This is my benzaldehyde. I have to convert this to 3-phenyl propane all. Let me see, 1, 2, 3 is propane, 1 all, 1, 2, 3, at 3 I have a phenyl group. Yeah, this is what I have to create. See, this has 1 carbon, this has 2 extra carbon. The first thing I have to do is I have to add 2 extra carbon. I can do using aldol condensation. I can use this CH3 COH and do aldol condensation and the heat also. With this, the product which I'll be getting is CH double bond CH, C double bond OH. Now I have a double bond here, right? I want to make it all single bond. I can just use hydrogen in presence of nickel catalyst. I can do hydrogenation. I'll get this product. The next is benzaldehyde to alpha hydroxyphenyl acetic acid. This is my benzaldehyde. This is alpha hydroxyphenyl acetic acid. First, let me draw acetic acid. This is my acetic acid. And then I have alpha hydroxy. At this alpha position, I have a hydroxy group. That is OH. And phenyl. This is my phenyl here. This is what I have to prepare from this. Correct. So let me see what I can do. So let me react this with HCN. And you add 1 extra carbon. Right? NaCN and HCl. I'll react with NaCN and HCl in the presence of HCl. What I'll get is this compound C, where this will become OH, H, and I have a CN will be added here. Correct? Because CN minus will attack this guy, this carbon. Now I have to create this. What I can do is I can just add, what I can do here is, yeah, I can, this is fine. Maybe there will be hydrogen here also, this is fine. Only CN I have to convert into COH. So I can do a oxidation. Or let me do water only. Let me add water to it. If I add water to it in presence of H plus, what will happen is the CN bond, if you see, right? CN bond, this will get H, this will get OH. Again, this will get H, this will get OH. So with this will come out. NH3 will come out and I'll get COH. This is a better solution actually. Yeah, this is better. The next is benzoic acid to M-nitrobenzyl alcohol. Let me try this. I have a benzoic acid. To convert this into M-nitrobenzyl alcohol. This is the benzyl alcohol. Benzyl alcohol CH2OH at meta position, ortho para meta, ortho meta para. Sorry, ortho meta para. This is meta. Yeah, this is what I have to form. So what I can do is I can first make it CH2OH. Pretty easy. I have to just do a reduction. I can use LiAlH4 right? This becomes CH2OH, and then I can do the nitration. HNO3 in presence of sulfuric acid. So it will come in the meta position. Let's complete the reaction. I have this benzene with ethyl group. I'm using KMNO4, KOH. So in this case, that doesn't matter what, howsoever big the chain is, it will become COOK actually. That is potassium benzoate. And again, if you add water to it, it becomes benzoic acid. Similarly, here also SOCl2 if you are adding OH, all this, both this OH will be replaced with Cl. So this is what you will get. Next is this C6H5CHO NH2CO NH2. I think we have done this reaction. We have done this reaction where we have told that this hydrogen and this will come out. We have shown the reaction mechanism. You can watch the previous video where we explain the reaction mechanism of this. I'm not willing to do it now. So with this you'll get N, you get NH and CONH2. Correct? This goes off, this attaches here, you'll get this. This is called benzaldehyde semi-carbazine. From here to here I have to prepare, I think we have given this reaction. So we need to add what is will be Friedel-Crafts acylation reaction. And if we add this with AlCl3, we'll get this. Right? So here, this is my toluene agent. It will convert this aldehyde to carboxylic acid actually. This will become COO minus. This is the product. In this case NaCN. So if I have COH here, right? So this will go in this way. Cn minus will attack here, right? And H from HCl will attack here. So what you get is this product. C, here OH, here H, here Cn, and this will be intact. This is what you'll get. So this will be aldol condensation. This is not having any alpha hydrogen. This has alpha hydrogen. So OH minus will first pick this alpha hydrogen. Correct? And this film becomes a minus. And then this will attack this. So if you see this H, now this will become slightly negative, slightly positive. And this guy, see, it's a minus actually. This will attack this carbon here, right? And that's how it will form actually this compound. When you heat it, you get this. You can draw the mechanism. You get this. Here NaBH4 will convert this aldehyde to alcohol. So we will just draw this structure to give you a clear idea of what is this. Okay, so NaBH4 will just convert this ketone to alcohol. It becomes OH, this becomes H. Other things remains same. These kind of reactions also we have seen. So we have to complete this. There is something, ozonolysis of which will give me this. So typically to get this, what we do is, you have this, You add one more. And remove this. So what you get is this. So that means ozonolysis of this will give you this. This is my X product, reactant. So when you on this you add O3 with zinc, you get this product. So the question is cyclohexanone forms cyanohydrine. So if you see cyclohexanone, you react with HCN, CN minus attacks this carbon and then H will be attacking here. So you get something like this, OH here and CN here. But 2,2,6 trimethyl cyclohexanone. Let's find this first. It's my cyclohexanone. 1, 2, 3, 4, 5, 6. 2,2,6. At 2 I have 2 methyl group and 6 I have 1 methyl group. But this does not react with HCN. Why? Because if you see, right, the attack is difficult. Why? Because steric hindrance. Because of steric hindrance, the attack is difficult. Correct? So this is why this SCN is not able to attack and cyanohydrin is not formed. The question says during the preparation of ester from carboxylic acid and alcohol, in the presence of acid, the water or the ester should be removed as soon as it is formed. So if you see the reaction, I have carboxylic acid, then I have alcohol, and it reacts, it forms ester and water. And this is an equilibrium reaction. So if you don't do anything, it will be in the constant state. To move the reaction in the forward direction, either you remove water or you remove ester. So if you remove any of these, the reaction will move in the forward direction. So since it is an equilibrium reaction, so for the reaction to move in the forward direction, you have to remove one of the products. Either you remove water or you remove ester. The question say organic compound has 69.77% carbon, 11.63% hydrogen, rest oxygen. That means percentage carbon is 69.77, percentage hydrogen is 11.63 given. So percentage oxygen is rest, that is 100 minus, you add these two, that is 100 minus 69 plus 7 plus 11.6, you get 18.6%. So these are 3% of carbon, hydrogen, oxygen. So if you see carbon, hydrogen, oxygen ratio will be what? 69.77% by molecular mass of carbon is 12 atomic, and this is 11.63 by 1 and 18.6 by 16. Correct? So this comes out to be approx 5:10:1. That means my empirical formula is of is nothing but C5H10O. It's some number n. This is my empirical formula. So if you multiply this 5 into what? 12 plus 10 into hydrogen is 1 plus 1 oxygen into 16. What you get is 86. And it says the compound molecular mass is 86 itself. That means the molecular formula here is equal to empirical formula. Right? So if this was not same, then we were supposed to multiply with some number, right? So this is same. It's all 86 into 1. If you see here is nothing but this into n is equal to 86. This is the 86 here. So n is equal to 1. This is my molecular formula also. Now it does not reduce Tollin agent. That is, it is not aldehyde then. Correct? So it is not aldehyde. But forms an addition compound with sodium hydrogen sulfide and gives positive iodoform test. So that means it is a methyl ketone, right? It's a methyl ketone. On vigorous oxidation, it gives ethanoic and propanoic acid. Ethanoic and propanoic acid gives on oxidation. That means one side it is the ketone also, if you say, right, it is something like this, methanoic and ethanoic. So if you see the compound gives methanoic and ethanoic acid, okay, let me draw this. So there's some compound gives methanoic acid and ethanoic acid. So if you see, total carbon is 5 itself. So the compound is made of these two only, right? Correct. So if you see, this has to be what? 5 carbon. Anyway, it has 5 carbon, C5. This is the molecular formula we have got, C5 best, It's 5 carbon. X is nothing but a 5 carbon, 1, 2, 3, 4, 5. And it has to be somewhere here. And that's why you get methanoic or ethanoic acid. Because it is methyl, that is sure. It is methyl ketone, right? There has to be one methyl here. So it looks like this is the one. This is methyl ketone, yes. If you do a vigorous oxidation, you will get the CH3, COH and C2H5, COH, yes. And then it will go for iodoform test also. So this is the possible structure of the compound. So it is pentane 2-ol. It's pentane 2-ol. Thank you. Visit our website examfear.com to watch more and more quality educational videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.